Hello guys, as I promised today we're gonna do some revision or the exam questions about the last topic we covered, composite function, okay? And I just take two exam questions from 2016 and 2017. Let's look at the 2016 question first, okay? Which is this one. This one is 11 marks and we only have about 5 marks about the composite function. Later on is regarding to the derivative or anti-differentiation, which we are not going to cover in this topic yet. So, but later I'm going to discuss in more detail. And now please pause the video and try yourself first. Okay. Now I will help you guys. Let's go through these questions. So the first one gives us the fx and give us domain. Okay. And this one give us gx and also the domain. Okay, now the first one is ask us to find fgx, so which is 4. Okay, so we plug in hx equals to f squared plus 1, which is gx, and becomes log e x squared plus 1. Okay, pretty straightforward. And this is only 1 mark. 1 mark means 1A. Okay, means it's only answer is correct, you get this mark. Okay, another one is state the domain and range. So this one is 1A, this one is 1A. So 1A means 1 mark for the answer. 1M means 1 mark for the method, or we call it steps. Okay, so next one, it asks us find the domain and range. Okay, so for this case, again, we can use our chain rule, or like not like chain rule, or like the chain box. Okay, I covered in last time. So x goes to g first, then gives us gx, then all of them go through f, so gives us f gx. Okay, so let's look at. So then we know the gx range must inside the f domain. Okay, so the f range, sorry, the f domain is 0 to infinity, and gx range, let's look at this one. Okay, x squared plus 1. So the range, the graph is looks like this one. So for the range of gx is greater or equal to 1, right? So greater or equal to 1. So which means the gx range is a subset of the fx domain. Okay, gx range subset of fx domain. And what do we have over here? So which means all the x values we can take. So the domain for our fgx right over here domain is R. Okay, now let's look at the range. So the range, since we got the function hx equals to log e x squared plus 1. Since x belongs to R, okay? So for our log function, we need to graph over here. So log is look like this one. So this one is 1, 0, which means all of this is greater to log e 0 plus 1, because x squared is greater or equal to 0, okay? So all of them are greater or equal to log e 1, which is 0. So the range of our function is 0 to infinity, okay? So this typical question, it tests us the domain and the range, but also combined with the composite function. That one makes this one is a bit harder. And later I will show you the report so you know how many students get this one correct in that year. Okay. So next question is show that hx plus h negative x. So hx again is log e x squared plus 1. And h negative x is log e negative x squared plus 1. So adding them together, our left-hand side equals to log e x squared plus 1 plus log e x squared plus 1. So it's become log e x squared plus 1 square, okay? Because log, you adding them, it becomes multiplication, okay? So this is our left-hand side. For our right-hand side, let me wipe this out. So for our right-hand side, we have RHS right-hand side equals to f gx square, okay? So it's become f, so we make this one square, so it's x squared plus 1 square. So again, we plug in, it's log e x squared plus 1 square, okay? So now we prove the left-hand side equal to right-hand side, okay? So that's why we call it show that, okay? So I think this question, the 2 marks is, or like you find the left-hand side, then you find the right-hand side, then you just make them equal, okay? This will give you 2 marks, okay? That would be the first question I like to discuss. Let's move on to the report. Okay, you will see over here, the first one is pretty straightforward. 95% of students get all this one correct. But move on to here, domain and range, only 15%, which means 85 of the students missed this chance. Or let's look at if people get partial marks, it's only 45%. So more than half students fail to answer this question correctly, okay? That's why we need really careful, okay? You need to make sure we get this domain and range correct, okay? And for this one, again, surprisingly, it's still quite low, but we need to use the left-hand side equal to right-hand side, okay? Most of people get 1 mark or greater or equal to 1. So just make sure you write your steps in sequential, logical sequential order, okay? Not like jumping through. So make sure you know how to show that and how to write it properly, okay? So that would be this question. Let's go to the next one. So the next one, question 7. Okay, now again, please pause your video here and try yourself, okay? And one more tips. So for exam 1 or exam 2, you got 40 marks, but you got 60 minutes. So normally 1 mark, we need around 1.5 minutes. So now you can pause the video. For these 5 marks, you should be done this one in 7.5 minutes, okay? But normally I'm stressing you do around 6 minutes, so you still have enough time to check your work, okay? But the maximum time allowed is 7 minutes and 30 seconds to finish all these questions, okay? Now let's look at this question. First, domain and relation, okay? State the range. So the range fx equals square root of x plus 1. Since x is greater or equal to 0, this one is greater or equal than 0 plus 1. So it's just 1, okay? The range is 1 to infinity, okay? Range, make sure you write in the set form, okay? Or you write like the range or y belongs to 1 to infinity, okay? Make sure it's square brackets and small brackets for infinity. Now this one, gx equal to x squared plus 4x plus c, and c is less than 0. The domain is literal number or literal letters, we don't know. For the largest possible value of c, such that range of g is subset of domain of f. So the requirement is gx is subset, gx range is subset of fx domain. So fx domain is greater than or equal to 0, so which means gx need to greater than or equal to 0. So which means x squared plus 4x plus 3 need to greater than or equal to 0, okay? Now, if we do the cross product, it's become x plus 1 times x plus 3 is greater than or equal to 0. So let's draw the graph over here. It's x, and it's -3, and it's -1 over here. Okay, since this a squared, ax squared plus bx plus c, a is greater than 0, so the graph should be like this. Okay, that's just a sketching. So for the greater than or equal to 0, I want this part, and I want this part as well. So my x can only take -infinity to -3 and union -1 to infinity. Okay, that will be OR. And let's look at our gx domain only can be -infinity to c. Okay, so in this case, it only can be -3. Why? If I take -1 as well, it's -infinity to -1. So my graph gonna look like this. So I still have this part is below the 0, but I want is greater than or equal to 0. That's why it's invalid. So my C can only be -3. Okay. And for the value of C found in the previous part, state the range of fgx. Okay. So let's write the fgx first. Fgx is square root of x squared plus 4x plus 3 plus 1. So it's become square root x squared plus 2 squared. Okay, makes sense. And because this one is x squared plus 4x plus 4, and this one become x squared plus 2. Okay, because the range of G is a subset of the fx domain. So which means the original x value G can take will be our domain of our composite function. So the domain in this case is x belongs to -infinity to -3. Okay? And we have the x squared plus 2. Let's look at this graph. So x squared plus 2 looks like this one. This one is 0, 2. Okay? Now we have -3. It should be maybe over here, and to infinity. So this green one is our values can take. Okay, so minimum here is x equals 0. Okay, so in this case, our range will be 2 to infinity. The minimum value is taking from x equals 0. Okay. And the last question is, now the hx is x squared plus 3. And let me clean all of this. Hx is x squared plus 3, and our range, domain is R. So we want to find the range of fhx. Again, use our chain box method. So x goes to h, then we get hx, then we got fhx. Okay, so again, f can only take greater than or equal to 0, and my hx is x squared plus 3. So my hx can give you greater than or equal to 3. So which means the hx range is a subset of fx domain. So our whole chain box works, which means the x value, whatever h takes, will always satisfy this equation, because x takes any values, goes to h giving the value is greater than or equal to 3, and satisfy the input requirement over here. So our whole box, whole chain flow works. Okay. Now we know that x is R, is our whole domain. So fhx, we plug the number in, fx plus x1 plus 3 becomes square root of x squared plus 3 plus 1 and square root x squared plus 4. Okay, becomes like this. So again, this part we know x squared is always greater than or equal to 0. So the minimum value can take 0 and plus 4 becomes square root of 4, which is 2. So our minimum value for this function is 2, and it's unbounded going to infinity. So the final answer for this one range is square brackets 2 comma to infinity. Okay, that would be all I want to talk about, and let's look at the report. Again, the first part is pretty straightforward and just 1 to infinity. The second part becomes less straightforward, and less than 30% of students get that one correct. And for this part and this part, again, around 30% of students get this one correct under the exam condition. So which means a composite function, it is hard for almost everyone, okay, or for majority of students. That's why I want to do this practice. And if you guys want me to do more, please let me know, and I will do other final exam questions just to emphasize my points and help you get through this hard topic. Also, if you guys like my videos, please subscribe or click the like button and write any comment if you want. Okay, thanks for your time, guys, and see you guys for the next video. Okay, bye bye, guys.